On the 4th of July, 1997, a machine built by human hands, traveling at over 16,000 miles per hour, slammed into the thin, cold atmosphere of Mars. Inside its aeroshell, a tetrahedral lander and a tiny, six-wheeled rover were on a collision course with a planet that had been a graveyard for our ambitions. This craft had no sophisticated retro rockets to gently lower it to the surface. Its final survival rested on a technology that sounded more like science fiction than engineering, a cocoon of giant, impossibly strong airbags. For NASA, this was an all-or-nothing gamble. After 2 decades of failures and a haunting silence from the Red Planet, this was the mission that would either revive our dreams of Mars or extinguish them for good. This is the true story of Mars Pathfinder. To understand the sheer audacity of Pathfinder, you must first understand the shadow from which it emerged. The 1970s had been the golden age of Mars exploration. NASA's twin Viking landers had successfully touched down in 1976, sending back the first-ever images from the Martian surface. They were marvels of engineering, but their complex experiments delivered a sobering verdict. The rust-colored soil appeared to be sterile. After Viking, a deep chill set in. The public's imagination drifted elsewhere, and a so-called Martian curse seemed to take hold. For nearly 20 years, every attempt to return to the Martian surface ended in failure. The Soviet Union's ambitious Phobos probes failed in the late 1980s. Then, in 1993, came NASA's most painful blow. The Mars Observer spacecraft, a billion-dollar flagship mission, went silent just 3 days before it was scheduled to enter Martian orbit. It vanished without a trace. The loss was devastating, not just for the scientists who had invested years of their lives, but for the agency's budget and morale. The old way of doing things, building enormous, decade-long battleship missions, was no longer sustainable. From the ashes of this failure, a new philosophy was forged, championed by then NASA Administrator Daniel Goldin. The mantra was faster, better, cheaper. The idea was to move away from singular, monolithic missions and towards a fleet of smaller, more focused spacecraft with tight budgets and rapid development schedules. It was a strategy of risk, designed to get more science done for less money, with the understanding that some missions might fail. The very first test bed for this new, scrappy approach to space exploration was a mission to Mars, one that had to be built for less than a fifth of the cost of the lost Mars Observer. It was called Mars Pathfinder. The challenge handed to the engineers at the Jet Propulsion Laboratory, or JPL, was monumental. Land a scientific station and the first-ever exploratory rover on Mars on a shoestring budget. The biggest hurdle was the landing itself. The Viking missions had used a complex and prohibitively expensive system of powerful retro rockets to hover and gently touch down. The Pathfinder team couldn't afford that. They needed a radically different and radically cheaper solution. The idea they settled on was the airbag landing system. The concept was brutal in its simplicity. The spacecraft would use a parachute to slow its initial descent, but for the final, violent touchdown, it would be encased in a cluster of massive airbags that would allow it to hit the ground hard and simply bounce. It was an idea that met with considerable skepticism. No one had ever tried to bounce a delicate billion-dollar piece of electronics on the rocky surface of another world. The development process was grueling. The engineering team, led by a young and brilliant engineer named Tommaso Rivellini, had to design airbags that were lightweight enough to fly to Mars, but strong enough to withstand a 60-mile-per-hour impact against jagged rocks. They conducted test after test in the world's largest vacuum chamber in Ohio, simulating the thin Martian atmosphere. Early prototypes, made from materials similar to those in car airbags, were shredded to pieces when dropped onto a platform of sharpened rocks. Failure after failure, the team iterated. They eventually landed on a solution, weaving the bags from 4 layers of a synthetic fiber called Vectron, a material 5 times stronger than steel. The final design was a cocoon of 24 interconnected lobes that, when inflated, would transform the lander into a 10-foot-tall, multi-lobed, bouncing ball of hope. Even after all the tests, no one knew for sure if it would work in the unpredictable reality of Mars. On July 4, 1997, after a 7-month journey from Earth, the world held its breath. The entry, descent, and landing sequence, the infamous 7 minutes of terror, began. As the craft hit the upper atmosphere, its heat shield glowed at over 2,600 degrees Fahrenheit, friction turning the cold Martian air into a plasma sheath. At an altitude of about 6 miles, moving faster than the speed of sound, a parachute deployed, yanking the lander from its aeroshell. The lander dangled from the parachute, descending through the haze. Back at JPL, mission control was a sea of tension. The signal from the craft had been lost as expected during its atmospheric entry, and now there was only silence. On Mars, the final, frantic seconds of the sequence were unfolding automatically. Just 8 seconds before impact, the giant airbags inflated with explosive force, forming the protective cocoon. 4 seconds later, a trio of small, solid-fuel rockets mounted on the parachute fired, not to land, but to kill all horizontal motion, ensuring the lander would drop straight down. A second after they fired, a cable was cut, and the lander, now in freefall, dropped towards the ground. It hit the surface of an ancient outflow channel called Ares Vallis with the force of a car crash. And then it bounced. It bounced high. The first bounce was over 50 feet into the thin air. It bounced again and again, a total of 15 times over the course of more than a minute. A bizarre, slow-motion ballet of engineering and physics before finally rolling to a gentle stop. On the surface of Mars, the airbags deflated, retracting like giant petals, and the lander settled on the red soil. At JPL, the silence stretched on, and then a single spike of data appeared on a screen. A carrier signal. A voice in the control room called out, "We have a carrier," and the room erupted. The tension broke in a wave of cheers, tears, and ecstatic applause. The gamble had paid off. Humanity was back on Mars. The lander, officially christened the Carl Sagan Memorial Station, opened its 3 metallic petals, revealing its precious cargo. And there it was, the star of the show. A 6-wheeled rover named Sojourner. Named after the abolitionist and women's rights activist Sojourner Truth, the rover was tiny, no bigger than a microwave oven on wheels. Its top speed was a mere ½ an inch per second, but it represented a paradigm shift in planetary exploration. For the first time, we were not just landing on Mars, we were driving on it. The moment Sojourner rolled down the ramp onto the Martian surface was an iconic one, broadcast to a world that was suddenly captivated by Mars in a way it hadn't been for a generation. This was one of the first major internet-era space missions, and the public's appetite for images was insatiable. NASA's websites, overloaded with hundreds of millions of hits, repeatedly crashed as people from all over the world downloaded the first new postcards from another planet. Sojourner and its lander base began their scientific work immediately. The rover cautiously made its way to nearby rocks, which the science team had given whimsical names like Barnacle Bill, Yogi, and Scooby-Doo. Using its alpha proton X-ray spectrometer, it analyzed their chemical composition. The results painted a picture of a geologically diverse and active past. The landing site itself, a jumble of rocks of all shapes and sizes, was confirmed to be the result of a catastrophic flood that had torn through the region billions of years ago. Pathfinder ES data provided some of the most compelling evidence yet that Mars was once a much warmer and wetter world. A few days into the mission, however, a crisis emerged. The lander's computer began to spontaneously reboot, threatening to kill the mission. The spacecraft was suffering from a rare and complex software bug known as priority inversion. In an almost unbelievable feat of long-distance diagnostics, engineers at JPL figured out the problem, wrote a software patch, and transmitted it across 100 million miles of space. They hacked the computer on another planet and saved the mission. Pathfinder was designed to last for a month. The lander ultimately operated for 3 months, and the rover for nearly as long, far exceeding all expectations before the brutal Martian cold finally silenced them. But its legacy was already cemented. It was a spectacular proof of concept. It proved that the faster, better, cheaper philosophy could yield brilliant results. It validated the airbag landing system, paving the way for the larger and more ambitious Spirit and Opportunity rovers that would use the same technique years later. But most importantly, Mars Pathfinder reignited a global passion for the Red Planet. It was the scrappy little mission that could, a testament to ingenuity and daring, that blew the dust off our Martian dreams and opened the door for the continuous robotic exploration we see today. It was our first bold step back.